In the previous video, we derived the expressions for the basis functions and for the derivatives that we will need for our discrete approximation. Now we need to think about integration. So keep in mind that we have a term that looks like Wi nj dA. This is for the temporal term as an example. And when we think about the source term, we have Wi dA. So how are we going to compute these terms? Let's start with the integral of W sub I dA. Now we know, based on our initial notation, that this is really the integral of the sum over I of Wi dA. And we can expand that. So it's simply W1 dA plus W2 dA plus W3 dA. Remembering that we're using both I, J, K and 1, 2, 3 for our node numbering. Okay, what else do we know? The other thing that we know is that the sum of Wi over I is equal to 1. Now this may not be obvious, but if you remember in the one-dimensional case, there was a little video, and when I plotted both the basis function n1 and the basis function n2, they were always summed to 1. And the same is true in the triangle case where you have 3 nodes. It'll be true in a quadrilateral case where you have 4 nodes. So basically what we're saying is the basis functions always sum to 1. It's clear at the actual nodes because there you have one value is 1 and the rest are 0. But they will always sum to 1. So using the knowledge that the sum over I of W sub I is equal to 1, we can say that the integral sum over W sub I dA can be written as the integral of W1 dA plus the integral of W2 dA plus the integral of W3 dA. And we know that this will be equal to the area. So, based on that, we can say the integral of n1 dA is equal to area over 3. For the other terms, such as the Wi nj dA that we find in the temporal term, we're going to use a formulaic approach to finding the integral. Basically, what we have is that the integral of n sub I to the L, n sub j to the m, n sub k to the n is equal to 2 times the area of L factorial, m factorial, n factorial over L plus m plus n plus 2 factorial. As an example, let's apply this to that temporal term, to the integral of W sub I n sub j dA, which we can write as ni nj dA. because the weight functions and basis functions are the same. So in this case, L is equal to 1 and N is equal to 1. So that will give us 2a times 1 factorial times 1 factorial over 1 plus 1 plus 2 factorial, which will give us 2a over 4 factorial. So what we'll get is that the integral of w sub I n sub j dA is equal to a over 12. So I will leave it to you to work out the term where you have ni dA.